Okay, grade 10. We are going to continue about polynomial. Now we are going to have remainder theorem. But before that, I would like to have Proverbs 25 verses 21 and 22. It says here, if your enemy is hungry, give him food to eat. If he is thirsty, give him water to drink. In doing this, you will heap burning coals on his head, and the Lord will reward you. So, we are going to talk about remainder theorem. It says that remainder theorem, if f of x is a polynomial and r is a real number, then when f of x is divided by x minus r, we get a unique quotient which is another polynomial q of x and remainder r, which is a real number such that for all values of x, so f of x equals the quantity x minus r times the quotient q of x plus function at r. So that is the remainder theorem. So if we have a polynomial function f of x and it is divided by x minus r, so we have a quotient plus f of r, that will be the remainder. So f of r is equal to the remainder. Now, shall we evaluate this using synthetic division? So we are going to write the numerical coefficient. So x to the fourth is 1. Take note, this is 4 and that is 2, meaning to say a cube is out. So we are going to insert 0. So remember that. And then you have negative 5. Again, from x squared to the constant. So you insert again 0 because the linear is out. So 0 and lastly 4. Now this is divided by x plus 3. This is like x minus r. So we put here for your divisor. Like before, you can have you equate that to 0, that will be negative 3. So we use negative 3 as our divisor. So we put a line here, bring down the first number here, and we are going to start multiplying. 1 times negative 3, negative 3. We add, that will be negative 3. Again, we multiply, that will be 9. And then we add again, so that will be 4. And then we multiply, that will be negative 12. And we add again, that will be negative 12. And we multiply, that will be 36. And you add, that will be 40. So this is your remainder. So meaning to say that f at negative 3 is equal to 40. So that is the remainder. We can also use substitution sample. So f at negative 3 will be equal to negative 3 raised to the fourth minus 5 times negative 3 squared plus 4. So that will be 81. That will be 9 times negative 5 is negative 45 plus 4. So we add 81 plus 4 will be 85 minus 45 will be 40. So this is your remainder. Same with this. Okay, so that's how to have the remainder. So meaning to say that if we have a remainder when we have a divisor in a binomial like this, x plus 3 in that situation, now we do not consider x plus 3 as a factor because there is a remainder. So let's have another one here. Using synthetic again, let's write 1, negative 3, 4, oops, I think we miss one number here. That will be negative 11. Sorry. Okay, divided by x minus 3. So 4 negative 11. So we put our divisor here. That will be 3. And we put a line, bring down the first number there. Multiply is 3. That will be 0. That will be 0 also. 4 times 3 is 12. You add, that will be 1. So this will be your remainder. So if we have f at 3 will be equals to 3 cubed minus 3 times 3 square plus 4 times 3 minus 11. So this is 27. 9 times 3 is 27. That is 12 minus 11. So you will notice that 27 minus 27 is cancelled out. 12 minus 11 is 1. So that will be your remainder. So here, f at 3 is equal to 1. So that is the remainder. Okay. So that is how to evaluate the remainder